recording started? Yeah, good to go.
Right, so thank you very much for having us. As Nick said, I'm Nick Rowe. This is my colleague Paul.
Hi.
We work for Amy, and we're here today to talk about the core value lines Rowe network, which we manage. So a little bit about us. I've been in the industry a long time, 40 years now, even though I can't believe it. And during that time, I've worked in various areas of the business, or various businesses, originally with maintenance, logistics, project management, the operations side, performance scheme, major projects. So I've done quite a bit around the rail industry and thoroughly enjoyed it. And no thought about giving up yet. Really enjoying it. So that's me.
I've been on the railway 11 years and 8 months now, 10 years with Network Rail. I was a scheme project manager, then a project manager with Wales and Western Route. And then I leapt over to the CVL and the joys of working for Amy on the CVL, March 24. So I'm a project manager, working mainly on major DVEG, but we also do DVEG for examinations for structures and earthworks.
Cool. Right. Thanks, mate.
Okay.
So what we're going to talk about today is I'm going to cover a little bit of who we are and what we do on the Core Value Lines Railway Network, because not everyone knows that it's not managed in the traditional way, should we say. So I'm going to cover that off just to sort of give you some context about the network and what we do. Then Paul's going to take us through the vegetation management aspect of today. I'm going to cover the earthworks and drainage remote condition monitoring and the system that we have in place. And then we'll have time for question and answer at the end. I have to say, it would have been really good if our earthworks engineer had been here, but he's swanning off around the world at the moment. So you've got me. So I know how it works. I might not be able to answer some of the more detailed questions around earthworks specific drainage, but let's see how we get on. So just to make a start then. This map on the right hand side here. This is Cardiff, so this is the sort of the greater Cardiff area. The main line, the South Wales main line through Cardiff, is managed by Network Rail, as it always was. But in March 2020, everything that I've highlighted in blue, which is collectively known as the core value lines, that all transferred from Network Rail to the Welsh Government, and then through Transport for Wales to a company called Amy Infrastructure Wales to manage the network. We do a variety of things on that network in very similar way to the way Network Rail manages a railway network. So we look after all the assets. So all of the assets are ours, everything from fence to fence, vegetation, tunnels, telecoms, track, the lot is all leased to us. And in a similar way, we sublease the stations to the train operators in the same way that Network Rail does. We have a projects team, so we've got Steve and Paul here from our projects team. So we deliver projects work in addition to the sort of the maintenance and asset management work. We do railway operations, so that's everything from train planning right through to signalling the trains and the control centre. So we actually have 16 signallers work for us. Obviously, we've got all the safety, legal, contractual stuff that you have to do to look after people and discharge your responsibilities. I particularly look after the regulated obligations of operating a network, which is something a bit new to me. I didn't really know too much about it a few years ago, but it's basically the way the Railways Act was set up in 1993 establishes the railway network as a marketplace, and train operators can then bid to run their trains on your network. But of course, as the infrastructure manager, you are a monopoly. You can only come to us to run a train from A to B. So of course, the law, there's a lot of competition law in what I do to make sure that we don't disadvantage or advantage certain train operators. And the regulator looks at the way we allocate capacity to the network to make sure we're not being discriminatory. So that's sort of my day job, which was a bit interesting. It's not something I knew too much about before. And then finally, we are managing a £1 billion transformation programme, and that is to upgrade the network. Every aspect of the network has been upgraded to operate from 2027 what will be called South Wales Metro, and it's a metro style operation. So in the future, you won't need to have a timetable. You'll know that there'll be a train every quarter of an hour maximum, and the closer you get to Cardiff, the more frequent the service becomes. So that's the network that we're designing for that South Wales Metro. I'll cover that in a bit of detail. So that's the sort of bit of us. Just to cover very quickly to cover sort of operations. We have the responsibility as the infrastructure manager in the eyes of the law to do the operational bits, and that's everything from allocating the capacity, development timetables, writing the long-term plan. We have bids from train operators. We have the control center. We manage the control center. So in the picture here, you can see this is the new depot that we built at Taffs Well, and just at the very top of the plot is a little grey box. That is our control center, and that was opened a couple of years ago. And from that control center, it's a joint control center with TfW Rowe Limited, the main train operator on our network. We have a joint control so that incidents can be managed in real time in the control center. And within that control center, you've got the route control manager equivalent that we call a DCM. You've got the flight engineer, you've got the electrical control, you've got the CCTV and platform information screens, you've got the train running controllers, and you've got the signallers, all in the same room. In terms of signalling, the signaller in the control here at Taffs Well looks after the Treherbert, Aberdare, Merthyr lines. The Rumney Valley is still signalled from the Cardiff Rock by Network Rail, and that in 2027 will transfer to us as well. So that will be the second signalling position. And then the depot, this whole depot area has its own signaller. So there are actually 3 signalling positions in the control. It's a bit complicated because obviously when there's an event kicking off on the Rumney side, the control manager then has to deal with the signaller at Cardiff rather than shouting across the floor to the signaller in the room. And that will become a lot easier from 2027 when that's transferred. We also manage a train performance regime. So one of our regulated obligations then that the ORR looks over our shoulder is to make sure that we operate a train performance regime. And that's of course all about reducing delays and cancellations. So we're financially incentivized to do that. And we have to provide plans that are signed off by the ORR. And quite uniquely, what we've done here is we've collaborated with Network Rail and with TfW Rail Limited to have a joint train performance improvement strategy so that we're all pulling in the same direction. And one of the manifestations of that is within the control, we have a detailed set of contingency plans, so that if scenario A happens, then we go to contingency plan 1, scenario 2, we go to contingency plan C. So all of those contingency plans have been agreed by all the parties. So there's no arguing at the side what we're going to do. We know exactly what we're going to do to recover the train service. The comms plan goes out, and then the frontline staff, the guards, the station staff know exactly the plan that they're communicating to customers and giving them advice about how to travel. So that's a bit about operations. The transformation program, right. South Wales Metro is what we are part of delivering, and it is it's part of a wider free, like a sort of a travel area. If you think the Oyster Card in London, think about that whole sort of wider travel area. So the Welsh Government and Cardiff Council want to create this travel area where people can move seamlessly between walking, hire bikes or hire scooters, the train, the buses. Taxis will be linked into that. Lots of free parking at the tops of the valleys. So that's the vision for the future. That you'll have this sort of travel area, and our part of that is to upgrade the network. The Welsh Government specified that this network, the Core Valley Lines network, has to operate 4 trains per hour, all day, every day. So that's from start of service right through to the end of service, 7 days a week. And because we've got 4 valleys, each valley will have a 4 trains per hour service from 2027. And of course, the closer you get to Cardiff, because the valleys converge, then the more frequent the service becomes, up to 16 trains an hour at Cardiff Queen Street. And that's like more than double what the current service is. And so it all stemmed from a franchise bid back in 2018. So because that was the government's requirement to have this 4 trains per hour service, we actually bid the scope that would deliver that level of train service that we are now delivering. So it all came from a franchise bid actually back in 2018. That was in our bid. It was contractualized in the franchise, and we're now delivering it. So what does it all consist of? So we are putting in more tracks. Obviously, the more tracks, the more trains. We're also doing line speed improvement works so that trains can get from station to station more quickly. We're doing lots of structural enhancements because when a lot of the line was singled in the 1960s, you still got all the structures and one track was taken away. We're now putting that second track back in, but of course the viaduct has not been maintained to double the weight that over the last few years. So although the route availability is not changing, you could have double the stress on a structure that hasn't been managed that way previously. We're resignaling as a method of reducing headway to get more trains through a section. We're electrifying the network, and we're doing it in quite a unique way. Part of the package that we bid for in the first place was to have bi-mode trains and a discontinuous electrification system. So what we've been able to do is not electrify the complicated, the difficult areas, so station throats, station canopies, low bridges, those places that are notoriously difficult to electrify don't have to be done, because when the train approaches those non-electrified areas, it'll switch to its alternative form of power. And in the two fleets that we have, they are battery. So the train will switch seamlessly between overhead pickup and battery power. I mentioned it a minute ago, we built our new control centre at Tafts Well. We've built a whole new SCADA network. We've got rid of all the signal post telephones, so we rely wholly on GSMR. We're doing general improvements of all stations. Every station will become PRM compliant. Level boarding, lifts, footbridges, PRM compliant footbridges have been put in a lot of places. We're building 2 new stations. So there'll be a station at Crewis Road, which is just to the north of Cardiff, and a new station at Butetown, which is on the Cardiff Bay line. The Cardiff Bay line will, in 2027, be converted to a tram operation. So one of the fleets that we are bringing in is a tram train. So when it's trundling around the heavy rail network, it will be a train. But in the future, when it comes off the main line and goes onto the Bay line, the driver will transition the train into a tram, and then the driver has to change the style of driving from a looking for line side signals to a line of sight type operation, just like you would drive a bus, because people could be on the track in that area. It shouldn't be, but that's the style of operation that the driver will have to do. And the reason why we're doing that is because the Welsh Government and Cardiff Council have a much bigger aspiration to spread out a tram system around Cardiff. So what we are contracted to do is build the transition so that once the train and the driver has transitioned from a train into a tram and is on the Bay line, there'll be no further transition then when the network spreads out into the street. So that's really interesting. And of course, it's only the first sort of it's only the second tram train operation in this country after Sheffield, which was done quite some time ago. I know a lot of the other tram operators are looking at it, but we're going to be second to have implemented that. We've got new fleet depot, which is where the tram trains will be serviced. It was known as Tafts Well Depot. It's now Walnut Tree Depot. Got to get that right. And it was opened by the King week before last. So that was very great to be able to host the King to sort of see our achievements. There'll be timetable changes. So to be able to get to the 4 trains per hour, that's going to be 3 or 4 big rewrites of the timetable to get to that. Lots of operational changes to make sure that the 4 trains per hour is robust and it can be delivered. We have an innovation. We have designed the signalling system at Tafts Well to be where the interlocking is done by a programmable logic controller. And it's the first time in this country that a PLC has been approved for mainline signalling. And now that we've got it approved for Tafts Well Depot, we definitely see PLC-based interlocking being rolled out across other schemes, bigger schemes, because the beauty of the PLC is that we have just one which controls the depot, but if you have a much more complex track layout, you just build more PLCs to control the more complex layout. So it's modular. And yeah, we see that definitely as an innovation for the future that will be of interest to network operators. And then finally, entry into service, which I didn't know too much about before I came onto this project, but that in itself is an art form to be able to get all of the assets to a state where the regulator signs off the asset before it can come into use. So that's been quite a job. Yeah, just a nod to Network Rail. Obviously, we are a separate network, but because it was built as one, you can't just put a dividing line between two networks and, never the twain shall meet. So we have huge interfaces with Network Rail. The track boundary is quite straightforward because it is a line on the ground. Every other asset is not straightforward. And because of the way the network was built, we obviously share a lot of resources with Network Rail, possession planning, for example. We share a lot of publications with Network Rail, the sectional appendix, for example. We felt that we didn't want to have our own sectional appendix because then you'd be looking in two places for information. So we felt that we wanted our network to be in the Network Rail sectional appendix, and obviously we have to pay for that. But at least it's all in one place. Similarly with the timetable, there is only one timetable. There aren't two timetables for each network. We pay Network Rail to keep our network in their timetable so that all the timetable is in one place, just for simplicity. And there are various aspects of the transformation project which we are delivering on Network Rail's network. Okay, I'm not going to cover this in any detail. There's a slide here about just the number of assets. If you're interested, these slides will come out later, so you can see that. We manage our assets in exactly the sort of way that you would expect them to be managed. We have an AMP process for each of the asset types. That covers inspection, planned emergency and projects work. We have rapid response. We are very much moving in the data-led decision-making way of thinking, where the data tells us what the right thing to do is, so there's less room for subjectivity, more hard and fast sort of data driving the decision-making. We do all the things you'd expect us to do, and vegetation management, obviously Paul's going to cover in a second. And we are on the ISO 55001 certification journey. So we're going for certification next year. So we're just doing a lot of the prep work for that. Just to cover off, I'm not going to cover this in any detail because obviously I'm going to talk a lot more about the flood, the bridge and the earthworks RCM, but we have a range of RCM because of the transformation program. A lot of the new assets come with RCM built in. So we benefit massively from that, so we've got extensive RCM on our signalling, axle counters, earth leakage detectors, points and points heating, CRT sites. So we have a huge range of monitoring out there, which has been really, really fantastic. All of the feeds come back to the flight engineer in the control, and the flight engineer can then decide what to do with an alert, whether it's urgent or whether we can leave it until engineering hours. And then we've also got more RCM coming. 2 of the trains will be retrofitted with a device that will measure the track geometry and also look at the condition of the rail head. And through machine learning, you can then stack the different runs on top of each other to see where the changes are occurring. So in theory, you can see things like missing bolts, wheel burns, whatever the railhead is picking up. The system will alert you to a change from the previous run. So obviously we're looking forward to that. And also there's something called a panto bot, which will sit on top of the train, and it records the movement of the pantograph and the contact wire. And then again, through machine learning and analysis, the system will tell us when there's a problem. If there's an unusual interaction between the two, if something is moving progressively more so over time, then the system will alert and tell us there's a problem, go and have a look at it. So yeah, it's good to be part of it. A lot of innovation happening. Okay, so that was quite a long introduction. So I'm going to hand over to my colleague now, Paul, who's going to take us through vegetation management.
Thanks, Nick. I learned a lot then, actually. A lot of people did, but yeah. Excuse, I don't know how sensitive the microphone is, but you might hear my stomach rumbling a bit as I wait for the samosas to arrive. But yeah, I'll just go through the vegetation management and a change of our approach since I arrived back in March 2024. So my main core work is the line side vegetation and complying with the standard 5201. We arrived when we originally took over, I think it was 2020, wasn't it? we found some of the roots weren't compliant with our standards. So the team prior to me obviously have started work since I arrived. This is the work that we've been doing on the core valley lines, is doing the clearance work, removing dead and dying trees, ash and that sort of thing. So yeah, as I say, certain things, obviously that's the effects if you don't remove your dead and diseased trees. So we found that there was a bit of a conflict between the client, TFW, and ourselves regarding our scope. Basically, we had an arborist who was trying to walk the route, do his surveys, feed that back into our scope. We weren't including the client so much, and I wanted that to improve, and that was something that I was looking for some innovative ways of actually achieving that. This was a tree storm just before Christmas in 2024, Fiddler's Road in Cardiff. I'm a Cardiff boy, so I'm quite passionate about the CVL and the improvements that we're making, and improvements to our line side neighbours, our commuters, regenerating the valley lines, and all that comes with it. And yeah, these unfortunate people just before Christmas had a tree land on their roof, so we mobilised our team. Managed to get a road closure with Cardiff County Council, got the tree down. I think we removed the tree on the 18th of December, and the family were back in the house just before Christmas. So it was a good news story, but what I was looking at is why those trees were missed. So I don't know whether the video is going to work. Oh, there it is working now. So we went to a presentation by a company called Railscape, and they have a drone arb element to their list of things that they do. We went there actually for weed spraying because they had a targeted weed sprayer drone that could fly around a structure where it was difficult to access vegetation on the structure. They could spray it, they could treat Japanese knotweed, they could do that sort of thing. But they also had this drone arb that they were developing. I think it was being used in Anglia route before ourselves. So I thought it was a great idea. Some of the things, I'll go through some of the things that the drone arb can do and why we're in a much better place with our relationship with TFW. So the drone goes up, there's no track access needed. One of my main concerns was our arborist was walking trackside. If you've got people on track, then there's always a danger. And if we can try and eliminate as much of that trackside walking as possible, then that's what we need to do. Basically, they send the drone up. It's away from off the infrastructure. Obviously, you can see us in the car park there. The drone will fly this flight path here, taking multiple images as it flies across the area that it's surveying, and we end up with that information being captured. The images are reviewed by drone arb's own arborists, who will formulate this dashboard. So we have a list of the trees, we have the type of trees. So we have triple D strikers, triple D third party strikers, ash, leaf fall as well is something that that they've developed, all done by AI to pull at the tree species and the topography of the area, and then give the arborist who reviews the data a more targeted approach. So he's not reviewing everything, but he will focus on the high risk elements initially, and then there'll be a follow-up mop-up session when our arborist will go out and he'll just double check the areas which are on the borderline, not high risk, not low risk, but somewhere in the middle, and he'll go out and review them. So this dashboard is then created. Each tree is given a unique identifying number. It will have a TEF form attached to it, so the recommendations from the arborist will be in there. It'll be categorized. We then send this across to TFW, so TFW for access to this. So their engineer will look at it. He will give the thumbs up. Yes, I agree with what the arborist has said. I want you to either, prune or lop the tree or fell the tree if he deems it's a high enough risk. So then he's almost like creating our work bank for us. So rather than there being conflict about what we should be doing and what we shouldn't be doing, they're actually directly instructing us. This is then sent to our contractors. Our contractors can then go and plan that work in. They can use this as a what tree word assigned to the tree. They can also click and select Google Maps if they choose. Future development is that we're going to develop an app, so the guys are out on site will actually see their exact location as in relation to the tree that they're supposed to be working on. Once the tree has been dealt with, whether it's pruning or felling or etc., then they can upload a shift report and they can upload photographs. If they need to create a felling zone, then they can add additional trees against that tree and just give an explanation as to why they've had to remove additional trees apart from the one that was identified. This has helped us out massively. We had loads of freedom of information requests from our valley's neighbours because there was so much work going on the valley lines, and they was thinking, well, why are you removing all these trees, etc. And we had no evidence to give them back. There was no we documented it, but it wasn't as efficient and as overarching as the information we're getting back now. So as I say, then TFW can access that card. They can see that that tree was removed. They can see the shift report. They can see the guys out on site. They can see the photos of the work taking place, the after photos of when the work has been completed, and they can see any explanation for removing additional trees. The drone arb also multidiscipline, really. You can use it across all disciplines because the red element is like a moisture content detector. So they use that to obviously identify which trees are drying out and which trees are healthy and have a lot of moisture inside them. But we can also use it for the track. So that's a nice dry track there. If it wasn't red, it could be a possible wet bed, etc. there. So it can be used across all disciplines. It's quite easy to access. We just, if you want an account created, we give you a link, you create a password, and then you can access the whole system. So this is the sort of thing that can be done. So you get these images, obviously not on the cards, but if you go into the system, you can run, and this is our compliance line there. There's also a 3D model that can be created. We're not actually using this because we don't need to use it, but we could use it for future developments if we want to. The good thing about the drone arb is we've flown it this year. We've flown the whole CBL, and it's taken us 6 weeks to fly the whole CBL. It's 127 miles of track, but linear cost for flying the drone arb is £850 per mile. So it's quite good because you get all this information back. There's a lot of work that goes on in the background. Saves our arborist having to walk. What probably found with our arborist is if he was walking down here and he can't see what trees are behind. So that was the struggle that we had. He could see the front line of trees, but anything was happening before. And that's what happened at Fiddler's Road is he could see the front line of trees. There were 2 dead and dying trees behind that set of trees that actually eventually fell on that house. Also, there's certain areas we can't access during the day, so he was surveying trees at night, which is not ideal, but all this can be flown in the day. There obviously are weather limitations, wind and rain, etc., affecting the drone, but our next flights are due now in the 2nd week of April, so that'll be our flights for next year, and they'll be done by mid-May then. So yeah, well, we can overlay that data, we can see the improvements made from the previous year's works. So there's lots of benefits to having that information to hand. As I say, the efficiencies of this single survey results in multiple virtual studies and removal of boots on ballast. Substantial cost reduction. It is a substantial cost reduction. A greater increase in identifying trees compared to the surveys our arborist was doing on foot. We can evidence-based, we can target areas. So, if we decide that there are higher risk trees, we can pinpoint those trees, we can target those trees. So rather than have a blanket clearance in certain areas, we can say right to the client, what do you want us to do? Budgets are tight. When in 2020, initially there was a lot of money floating around and a lot of work was being done, but as time has gone on, those budgets are being squeezed, so they want us to target vegetation more than doing blanket de-veg. Carbon footprint, the reduction in work. Something that's not on there is the impact of our works on our line side neighbours as well. You know, the less trees we're felling, the less noise we're making, the less dust we're creating. All those things have to be factored in. And I think our relationship with our line side neighbours is improving. And environmental savings, yeah, the environment. You know, I once said, "Oh, it's like a jungle out there" to someone, and they immediately fight back. It's not a jungle; it's a habitat, Paul. So, you know, which it is, and that's what we try to help achieve with the planning work that we do now. So, artificial intelligence is used by the drones, as I say, identify species, type, topography, location, any third-party properties, infrastructure, assets that are in the area, just so the arborist can do a more targeted approach to his review. Biodiversity net gain, where we've got dormice, lots of dormice on the CVR. We've got a dormice license, and part of that license is a woodland management plan, where we're opening up canopies to hopefully get a bit more light on the ground so the plants can develop and grow. So the drone arbor in the future would be able to give us species areas on the CVL where our ecologists can then say, if we were to open up this canopy, then we could increase the type of vegetation in that area to help with certain species of animals as well. Oh, right, that was an interactive one. There we are. As I say, other disciplines can use this. The footage is, you know, that image quality is fantastic, really. So yeah, I've used it to add a lot of historical close calls that were still assigned to our team. And when I first joined Amy, and I've been able to go out and review. Well, not go out. I don't even have to go out. I just go onto the system and review certain ones in certain areas where people have said there's logs, and just double check to see they have been removed. Obviously, the catch pit lid is loose there, so it can be used to identify close calls as well. Right, that's enough at drone up. So another issue that was on my lap when I first arrived was our weed spraying and our approach to weed spraying. I think we had tried mechanized previously, but there was an issue with the supplier, so we went back to knapsacks. And the issue with having, once again, you've got track workers working on site, the consistency of spraying, the effectiveness of spraying. And I think I went to Rail Live and I met up with QTS, and they mentioned that they had this weed spraying machine that was being used in Scotland. And I thought, well, let's give it a go. So we've just done our first year of weed spraying. We've done 2 sprays. We do a spray in April and a spray in September. And we are seeing good results now. Obviously, one of the major benefits of this is reducing the boots on ballast, but this is road legal, so we don't pay transportation costs. It gets delivered from Scotland to us. We keep it for 5 or 6 weeks, and for every night it works, it drives to site. You fill it up, it sprays, and it drives back to our depot. So there's none of that transportation cost. It can also work under live OLE. Not in that image there, it can't. You can't use the lances, but if they're spraying using just the downward spraying jets on the rear of the vehicle, then we've got authorization to use it under live OLE. Obviously reduces isolation costs and also gives us increased time on site. We're not waiting for a Form C before we start any work. Well, I think that's not working. As you see, the controlled spraying, they can turn on the jets either side if there's a water course and they can't spray on the down, if they can only spray on the up, they can do that. We can travel at 5 miles an hour spraying, and I'll show you some photos at the end of the presentation. It just demonstrates this has been pretty effective. I'm quite pleased with the results so far in the first year of using this machine. We have a limitation on the size of the bowser, but we're planning our work so we can get to an access point with the bowser that follows the vehicle on the road, and then the guys just refill it at the designated access point. Yeah, as you can see, it's a consistent spray and an effective one. You'll see in the photographs now. So this was Carlton Station, high profile. There was a member of the Senate or an MP who was living in the area. To be honest with you, if I was living there and that was my station, I wouldn't be happy. So obviously the knapsack spraying hadn't been working. So I use this as a bit of a case study just to demonstrate how effective it was. So the first spray, you could see there is a definite reduction in the weeds there. And this is after the second September spray as well. So I think you can certainly tell, and hopefully I'm hoping that when I take next year's photographs, we can see even bigger improvement. But you know, we're creating safer walkways for our teams as well. You know, if they need to go out, they're not stumbling through large amounts of vegetation as well. So yeah, I'm really pleased with how the machine has performed. And that was another section after our first spray. We could see that there definitely there's some effects of the weed spraying in that area as well. So year on year, I'm hoping as we do it more, you know, it will just get better and better to a point where, you know, we've got a line side that the weeds are not growing in the track and the forefoot, etc. But yeah, I think that's my last slide. Yes, there is. Thank you. Any questions, or do you want to do questions at the end? Or
We normally wait.
okay, no problem.
Thanks, Paul. Thank you very much. Right. So the next bit we're going to talk about is earthworks and drainage RCM. As I said at the start, I'm not the earthworks engineer, so please just bear with me. So the remote condition monitoring that we've installed on the EVR network covers 4 areas. So we're very interested in obviously track flooding, flooding at bridges where bridges present an issue. We wanted to monitor CRTs, and we wanted to monitor drainage from earthworks. So that's the sort of the 4 focus areas. And the reason why we felt we needed to move away from a traditional way of managing is that, particularly with flooding, the first time you get to hear that the track is flooded is when a driver calls it in. And by that time, the risk has probably already occurred, you know, and do they even see the flooding at night? You know, how do you tell the track's flooded at night? So that has always been kind of an area of concern of how we're actually managing risk, particularly at the known sites that do flood regularly. And then, of course, once you've had the shout to say that the track is flooded, you've got to mobilise your teams, get people out there. And, you know, if it's flooded, it's likely that it's going to be poor weather. You know, so we're sending people out in the rain and the wind to go and stand out in a remote location somewhere in the middle of nowhere, typically at night, you know, when the wind's howling. It's not a great situation to put someone out in there. I actually remember a long time ago, I tried to get to a watchman at a bridge near Exeter. Couldn't get to him. They're actually isolated on an island. It's like, must do better than that. So, you know, with all of those things in mind, we felt that a transition to remote condition monitoring was the right way forward, because it allows you to be monitoring 24/7. You know, the system will alert at all times of the day or the night, so you don't have to rely on a driver's report. And because you can see the water levels, you can then become proactive, so that you get a period of time before the culvert is overwhelmed, for example. So we're able to act more proactively. We've tied together the actual monitoring of water levels with weather forecasting, local weather stations. So we're getting the benefit of both bits of data. And of course, our safety performance is improved because we're not sending people out on sites when we traditionally would have done. So that was what sort of drove the move towards RCM. So on the Core Valley Lines network, we have 26 sites that are measured in one way or another, and I'll cover that off in a second. And we also have 7 weather stations, around the same area. So there's a good correlation between the problem sites and the local weather. All of those feeds go back to the flight engineer at the control, and what the flight engineer will do is they'll be monitoring the systems, and as soon as an alarm pops up, for this or for any of the other RCM, they will then decide how urgent that is. If it's a flood alarm, then there's a process to be followed. If it's I don't know, like a point machine is causing a problem, then what the flight engineer will do is they will talk to the control manager, and they will between them decide what's going to happen. So typically with an impending point failure, is if that failure is occurring in the morning, then you probably want to get in during the daytime to fix that point before it fails, in the afternoon. Whereas if that warning comes up sort of late in the evening, then you wouldn't disrupt the train service. You'd leave it until engineering hours to go and attend to that point. So there's like an interactive conversation in the room based on the information the proactive information you have, and how we're going to manage the train service. So that's working really well. And also we have EWAT, Emergency Weather Action Team. So we convene these when poor weather is forecast, and there's a process contained in the actual online portal that I'll show you in a second to say when you have to trigger an EWAT. So there's no doubt about whether we're calling an EWAT or not. This condition is met, we call an EWAT, the control manager gets everyone together, discuss the problem, discuss the response to that, proactive measures, what can we do to mitigate, talking to the train operator, because there could be an effect on the train service, obviously. And the sooner we have that conversation, the sooner comms can then go out to the passengers and the station staff to sort of say, this has happened, and this is what we're doing to manage the train service, this is what you should do if you're traveling to, wherever. So that's how we manage it within the control. I've just got a couple of sample sites here. This is a culvert at Trehafod. So you can see this is the sort of normal condition, so the water is, flowing nicely through underneath the track. This is like cross-track arrangement. What we found is that the actual drainage as built, even though it was built 150 years ago, it's not bad. Everyone talks about climate change and having much more deluge type downpours in the winter. That is true. We can definitely see that happening. But what we found is once we got all the drainage working as built, it's not bad. It's not as bad as we thought it was. So in the early days, we did a lot of jetting and clearing of drains. The crucial thing here is because of the trash grill or the debris grill, that's the thing that tends to cause the backlog of the water. So as soon as we get a trigger, we can send the teams out to clear that, and then the drainage system actually does work quite well. And you can see how high this water gets. This actually overflowed and resulted in this. So you can see all of the muck in the track there that was left by the flood water because this culvert was overwhelmed. So this is one of our regular sort of flooding sites. What we've actually noticed on the valleys is that, traditionally, in my experience, you normally get track flooding when the river level rises, and because quite often railways were built on floodplains. So when the river level rises, it floods the track. What we're seeing a lot of here in the valleys is the torrent of water coming down from above, is the cascade of water from the catchment area flowing across the railway on its way downhill to the river. We get that sort of flooding, which is, I've never seen that before. So this is the same place. So this slide shows you a couple of things. The first iteration of our flood monitors were based on floats. So you've got these 3 tubes here, and as the river level rises, you can see that the floats will be triggered. You see? So that is how we determined the water level previously with the floats. But the floats can themselves get stuck, or there can be debris caught in the float. So what we've moved to in later iterations is a camera. So not only do we get eyes on the site through the camera, you can work out water level from the video in. And it's a much more reliable solution going forward. So that's the sort of thing that we're moving towards. So that's how we get our information. Similarly with bridges, this is a bridge that regularly has water up over the deck. So you can see we've got a marker on the bridge here, and this is the camera above the marker. And in this arrangement, you can see that as the water level rises, the camera with a radar in this particular iteration shows the level of the water. That's basically how it records the data. There's just a couple of pictures here from a live situation. You can see this isn't very easy to see, but you can see here this is sort of normal water level. This is in flood, and you can see that I'll show you the dashboard in a second, but on our dashboard, the water level has been alarmed. The alarm has gone off for water level. You look at the camera, yes, it's certainly a long way up before the danger area. And then as the river level continued to rise in this particular situation, you can see that the monitor has gone red. And again, looking at the camera, the water level has gone even higher till eventually it's more or less overwhelmed. So, so that's the marker now completely below water. So because we can see that build up happening, we get the trigger on the first level, we can then start talking to the train operator about what we're going to do, because we know this track is going to flood. So you can then, you're giving them sort of valuable hours to organise taxis, buses. One of the things we used to suffer from is because we've got sort of dead end valleys, a train would be on the valley line, we'd have a flooding report come in, we'd close the line straight away, you'd have trains then stuck up the valley. And of course, there's a massive risk then that people are going to pull the doors open and, detrain themselves. So having this knowledge is golden for the train operators, because they can then stop the trains going up the valley that would get stuck. They can put the buses on, get the taxis organised, brief the station staff to what the contingency plan is going to be. So this is really good. This is really good stuff for a train operator. This is the portal that we look at. So the portal has a dashboard of any headline alerts. There's a map showing you where all of the sites that we're looking at and their condition, whether they're green, amber, or red, depending on the water levels. We have the weather stations on there. The 7 weather stations are on this portal as well. There's the alert system that the control will look for, and there's an analysis function. Now, what I'm going to try and do now is go to the live dashboard, and we'll see if this works. Oh, it's looking good. It's looking good. Right, okay, that's not bad. Okay, so I'm just going to sit down for a second to operate the laptop. So let's push that down. So this is the dashboard. So you can see straight away we do have an alarm. This is a place called Penry Khyber. So if I click on that, what we should be able to see is what's the alarm. Yes, water level. So it's gone yellow. That has triggered an alarm at the first level. So if I go to the process flowchart over here, this should tell us what to do with that trigger level. Yeah, here it is. Look, see, so this then tells the control what to do if that alarm has been triggered. So that's the dashboard. So this is quite slow responding. Bear with me. Come on. Right, so that's the dashboard. So everything else looks okay. Yep. This is the map then I talked about. So here you can see all of the sites that we're monitoring and the condition of each of those sites just in one place. So you can see that all of the locations are fine, apart from that water level at Penry Khyber. So and obviously the worse the weather turns, the more yellow and red you'll see start to spread out on this map. This tab is the weather information. So we can see there are 7 weather stations. So they're listed down the page, and you can see what the condition is at that exact weather station local to us. I forgot to mention that all of these monitoring is battery powered, but you do get a low battery warning. So we're never going to be without a monitor, because you go and change the battery when it tells you to. This is a list of the sites. So rather than map view, this is a list view. So you can see down here how all of the sites are doing in real time. If there's no activity, if there's no kind of flooding at the site, the system doesn't send in pictures continuously. It only starts to give us updates when it knows there's a problem with the water. So some of these might be recent, some of these might not. Let's just click on one at random. Just going to click on this one, see what it shows. Yeah, so you can see there's the water level. That picture was taken 10:06 this morning. So you can see that looks fine. So if you ever need to look at a particular site, you can get the image. And then just to prove that we do actually look at this, the flight engineer has to sign off to say that they've responded to a fault. So here are all the responses. So something's been triggered. Our flight engineer ticks it off to say, you know, it's been attended to. You know, contingency plan has been brought in, or you know, whatever's happened. So that is our online portal. And as I say, that's available in the control. Right. Let me just go back a second. Let me just make sure I've got this. Yes, that's right. That's it. Got it. Yeah, cool. So this is what we end up with. So through the analytical tools that we have, this is a trace from one particular location. And what this is showing is this is the rainfall, and this is the water flowing in that location. So what you can see very clearly here is a spike in the rainfalls. There's been a downpour at this location, and within 4 hours time, you've got this peak of water flowing through the structure or under the structure. So that is a direct correlation. And because we've been running this now for 3 years, we've got very detailed plans about what's happening with the data from the weather station and how that affects the actual level of the water in the culvert or under the bridge. And what that's allowed us to do is develop this risk ranking. So when you're looking at the rainfall monitor, if it's in the yellow area, we know that's probably going to be okay, but we will definitely talk to the train operators about potential for a contingency plan. But if the peak rainfall doesn't move outside of the yellow area, we know the track is not going to flood. Okay. As soon as the peak rainfall moves into this red area, we know without a shadow of a doubt that track is going to flood. And we can talk to the train operator to say, in 4 hours' time, we are closing this railway. So, you know, do whatever you need to do to pull the trains out, bring the contingency plans in, prep people for that closure. And that is gold dust for a train operator to be given that kind of notice that they never would have had previously, you know. So if you like, this is the combination of all of our hard work. It's the monitoring of the water in the system and the rainfall, and this risk ranking that we know absolutely guarantees that we won't be closing the railway at this level, but we will be closing the railway at that level. So that's the culmination of all of our hard work. That's more or less it. I just wanted to finish off on a very happy note. This is a ranking of all of the train operators in the country for last month and the month before it, and the Core Value Lines is top of the table. So we are delivering more trains on time to 3 than the rest of the country. So
that heavy rail.
Correct.
So it doesn't include
DLR?
Yes, DLR.
Doesn't include DLR. So this is heavy rail only. Yeah, national network heavy rail operators only. Yeah, that's it. So yeah, for 2 months running, we've brought the highest number of trains in on time in the whole country. So, and that's also during autumn, you know, so we must be doing something right. That's it. Thank you very much for having us. I think we're on to Q&A.
Yeah. Thank you very much. Do we have any in the room first up?
I've got one. Sorry. Thank you, Nick and Paul. With the drone art, is there any integration with things like TIVR? Or is that just a manual check? So obviously you've got the drone view.
Yeah.
And TIVR, you've got a view potentially from the camera on the front of the train. Is there any way to interlink it, or do you just go
AI? Yeah, that's through me then.
Sorry,
Yeah.
excuse me.
There isn't currently, no.
Right.
We are trialing something next year whereby we can create a cab footage view with using the drone footage.
Mhm.
But that's not linking the two systems together though. So no, it's not something we've considered doing.
Okay.
Yeah.
Oh, because AI
Yeah.
is quite useful, isn't it, to go and see some of those visions of what it was looking like on certain days, and okay, you have to get the train routed again with the thing on it.
Yeah,
But yeah, just wondered if there was. But then actually, if you know where you are and you've done your drone survey, actually you can find out where you are with AIVR. Anyway.
that's right. Yeah.
We do use it for close calls. So if people phone in a close call, then we will look at the video footage to see, you know, how damaged is the fence or whatever.
Yeah.
And we also use it for when we're planning work sites, because you've got the measurement tool in AIVR, you can work out whether it's 2 meters or not to the work that someone wants to do.
Yeah.
There's certainly something we could look into, maybe linking the two together, you know, so you have your AVA footage and you could click on an image of the drone harvest. It appears there as well, you know.
Excellent.
I'm trying to see the online question.
There was Effie, excuse me, apologies for the name. Effie, you have a question. I don't know if Gideon has answered it for you. Would you like to come off mute and ask it?
Oh, yes. Hi, everyone. I'm Effie Zura. I joined CAD Keole Semi Docklands like 6 months ago as business transformation and innovation manager. Nice to meet you. So yeah, I had 2 questions. One was answered. The other one was about the data. I assume that the data from the drone is transferred to the platform via like manually with they are stored initially in a local drive.
It's a web-based application, so the drone footage is processed by the company themselves, and we get access to that data and the dashboard.
Okay. So it's more automated. Okay, yes, thank you. The other one was about the species classification, but Gideon has provided the response. Yeah. So yeah, thank you. Very interesting presentation. Thank you again.
Thank you.
Thank you.
Any further in the room?
I know you mentioned the deep weeding for the spraying on the ground level.
Yes.
As a very point of view, is there any devegetation automated where these trees and falling over last season, after they clear the vegetation? Is there any automated periodically they do it in devegetation?
No.
Or higher level, low level?
So the high level,
Yeah,
high level, we manage that with our de-veg teams, our contractors, to get into a compliant state. The weed spraying is just to maintain, to get the, as you saw in the first photo, it hadn't been done, or it hadn't been done effectively for maybe a couple of years, and then you can see how quickly it grows, you know. So that's obviously impacting tracks, furniture, all assets. You know, we can target certain areas. If we need to use the lances, we just book an isolation. So some of the remote monitoring sites, we spray those as well at the same time to keep them clear, so that the cameras can still see. There's also, we could do it for signal sighting and that sort of thing as well. So if we get instruction from the signaling team, then we can arrange for that to be done at the same time.
So the
The maintaining rather than
how many times the spraying?
twice a year. We do it in April and September. So we'll do that year on year. Now we've got a license for the next 3 years.
High level vegetation, just manually they do it.
So one off to get it into a maintained state, and then that will be passed on to our maintenance guys then to do their regular cyclical maintenance activities.
Okay, thank you.
Okay.
We have another online question. David, do you want to come off mute?
Yeah, it was just a question really. The drone footage is all very well and good, but as Nick knows, dormice is one of the sore points on the Cardiff Valley route. How does it help with identifying the restrictions using the drone footage?
No questions allowed from signal engineers, Dave.
So the drone out footage is purely for us to identify devegetation and where it's compliant and non-compliant. We know our dormouse areas. We've got a dormouse license in place, and we know the restrictions in those areas. So that information is then passed on to the contractors before they go to site.
Okay, no, I was just thinking, with all the problems we've had with dormice and signal sighting, it's just a case of I wanted to know if there was any reaction, because you still got to send the ecologist now to trackside to say, oh yeah, you can cut that down.
Yeah, well, we've got a Domos license and we've got a Domos method statement, so we know at certain times of the year when we can cut down to 300 mil, when we're not allowed to cut at all. So we try and plan our vegetation around those limitations.
Thank you.
Okay.
Just a quick one from me. So you've got the alerts for the RCM when the battery levels are running low, so you send people out to do the battery. Other than that, is there any maintenance schedule for cleaning cameras or all that equipment must need some ongoing attention, I guess?
I mean, not really. I mean, there's the vegetation control just to make sure that it's not obscured.
Yeah.
The battery.
Yeah.
I'm not aware there's anything else.
I know that doing something with the remote monitoring and whether there is, if flight engineers are spotting anything on the cameras, then we can send a team out to clean them.
More reactive.
Yeah. I'm not sure whether there is an ongoing and cyclical sort of plan for that. I was
Probably not. Fix the failure sort of thing like this.
Any more?
No, Gideon's nicely asked for Effie's email address to share another presentation. But no, there's nothing else on that.
Okay, so with those in the room, we'll do a quick round of applause. Any virtual hands online, please? Yeah, thank you very much. Really interesting. And that system, I've not seen anything like that. I don't even know whether Network Rail have something like that, but that's incredible, really powerful.
Yeah.
And the proactive nature of it now with the data sets.
Yeah.
I'm sure that'll reap benefits in the future.
Definitely. Yeah, already is, definitely.
Yeah. Okay, thank you very much.
Thanks everyone.
Time.
Thanks very much. Thank you.